All right, Honor Stats, this is chapter 6.3. We're going to do a couple more things with the binomial distribution. The first thing we're going to do is we're going to make a histogram for the binomial distribution. And the second thing is we're going to compute mu and sigma, which is the mean and the standard deviation for a binomial distribution. And those two formulas are very, very straightforward. You'll have no problem with it. Okay, so making this histogram for a binomial distribution, we're going to place our R values on the horizontal axis, the x-axis, and our probabilities of each one of those values of R on our vertical axis. We're going to construct a bar over each value extending from minus 0.5, minus a half, and plus a half. So basically, in a sense, when you have the histogram, that's what's going to be here, the 1, and then the 2, and so on. So it's going to extend negative 0.5 and positive 0.5 away from each of your whole values of R. So our example for the day, a waiter at the Green Spot restaurant has learned from long experience that a probability that a lone diner will leave a tip is only 0.7. So that is our success. The probability of success is 0.7. So that means we know the probability of failure is 0.3. So it's 0.7, leave a tip, 0.3, do not leave a tip. During one lunch hour, the waiter serves 6 people. So 6 is our N. What are we going to do? We're going to find all values from 0 people of the 6 leaving tips all the way up to 6 people of the 6 leaving a tip. Okay, so each of these particular values, let me show you what each of these are. This is going back to chapter 6.2. So of the 6 people, 0 leave a tip. So that's 0.7, that's your success. 0 leaving a tip, there's our failure. All 6 do not leave a tip. When you put that in your calculator, you will get 0.001. Then you're going to do 6C1, 6C2, 6C3, 6C4, 6C5, and 6C6. This is going to be 0.7 to the 1, 0.7 to the 2, 0.7 to the 3, 0.7 to the 4, 0.7 to the 5, 0.7 to the 6, 0.3 to the 5, 0.3 to the 4, 0.3 to the 3, 0.3 to the 2, 0.3 to the 1, and 0.3 to the power of, sorry about that, 0. This one is here, 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 and that one's there. Leaving each of these probabilities, i.e. percentages, for each of them, okay? So in order to make this histogram, which we're going to do next, you have to find all probabilities. Let's say there were 8 people that ate breakfast here, or ate during that lunch hour, and that you wanted to get the number that left the tip. You would have to do 8C0, 8C1, 8C2, all the way up to 8C8. You're doing every single one of them. And then we're going to use on top. So 0.0, and then 0.1, and then 0.6, 185, and then 320. Then we got 0, and finally 1. Those values, each of the 1, 0 goes above, goes here, 4 goes here, 0 or 8. And we're going to build a histogram. So please know that 0, so you're going to go 0.5 this way, 0.5 that way. That's your first building. All right, and so on and so forth. Okay, so what you want to do is you want to make sure that you goes here, 0.001, goes above the second one, 0.010, the third one, 0.60, 0.185, 0.324, 03, sorry, 0.303. Remember, you always want to label the top of a histogram. 0.118. So in a sense, ladies and gentlemen, you are going to find each probability for the binomial distribution, starting from 0 all the way up to the total number there are. You're going to turn them all into 3 decimal places, and then you're going to draw a histogram with the y-axis being your percentages and the x-axis being your whole values, 0.5 to the left and 0.5 to the right, to build your histogram. Oops. And the last thing we're going to do is we're going to find the mean, which is denoted by a mu, and a standard deviation for a binomial distribution. The formulas are super easy, and here they are right here. The mean is simply n times p, and the standard deviation is simply the square root of n times p times q. So if you think about the problem we just did, remember the n was 6, the p was 0.7, and the q was 0.3. n 6, p 0.7, so the mean, which is the balancing point, is 4.2. And this guy is going to be the square root of the 6 times the 0.7 times the 0.3. Plug in our calculator and we get 1.122. All right, so the mean and the standard deviation are very, very straightforward. So in chapter 6.3, you're going to have to do two main things. You're going to have to find the probabilities of every single event in a binomial distribution up to 3 decimal places. You're going to draw a histogram using those probabilities, and then you're going to find a mean and a standard deviation by using those 2 very simple, straightforward formulas. And that's it. 6.3 is done.